So now we're working on 1B, and this is 1B part 2, because you would have done, we already did 1B part 1 in another video where we were doing empirical and molecular formulae. And so in that video, we had gotten what the molecular formulae of P was supposed to be. And so from B part 1, we know that the molecular formula is C2H6. So that's the molecular formula of P. So we can draw that out. They're asking us now to draw the displayed formula of P. So I'm going to draw this out, showing all the bonds and everything there, okay? Whenever we're asked to draw a displayed structural formula, that's what we have to do. So here it is. It's 2 carbons, right? And then I'm going to just fill out everything else with hydrogens. So there needs to be 6 hydrogens in the end. Okay? All right, so that's what we would submit for our answer here. That is the displayed structural formula of P, again, which we found the molecular formula in part 1 of this question. So this, if we were to name it, we know right off the bat that that is an alkane called ethane. Okay? All right, so that's all that was expected of us here. So let's move on now. We're going to move on to part 3 of this question. And part 3 is asking us to outline the reaction mechanism for the reaction of P with liquid bromine using appropriate notations and equations. Okay? So when we're being asked now to outline this mechanism, it's important that we know what functional group or what homologous series P belongs to. And as I said earlier, it turned out that P was ethane, which belongs to the alkane homologous series or alkane family of compounds. And that's going to be reacted with liquid bromine. So we're going to react that with Br2 liquid. Okay? Now, we know that if alkane is going to react with Br2, right, liquid bromine, there would need to be the presence of UV light or sunlight. That's the only condition under which this reaction can go. So that's an assumption that we're making in order to outline this mechanism, okay? So let's get started. The first step that we're going to show, as a matter of fact, the reaction mechanism, we have to know what it is before we even start to think about drawing it, right? The reaction mechanism here is going to actually be one called free radical substitution, okay? And that's how alkanes react with halogens, okay? So free radical substitution. So that's the reaction mechanism that we're going to display. We're going to show everything, right? All the electron movements for a free radical substitution involving ethane and liquid bromine. So step 1, whenever we're doing any free radical substitution, there are 3 steps that it has to follow. And the first step is known as initiation, okay? Initiation, that's how the whole thing is gonna get started. So we need to have our initiation step. Okay, and in the initiation step, here's what's happening, right? We have our Br2 or our bromine liquid, it's Br. And then we have, that's how it is, it's covalently bonded, right? Now, in the presence of sunlight or UV light, so we normally write that above our arrow, we need that for this to happen, okay? For anything to happen here. So when UV light is present, what's gonna happen is that this bond here is gonna split homolytically. So an electron, one of the electrons is gonna go to one of the Brs, and then the other will go to the other Br. And that way, because we have homolytic fission, let me just write that here, homolytic fission, right, where the electrons are split and shared equally, we end up with what we call radicals, and we're going to get 2 bromine radicals, okay? So that's our first step, is generating this bromine radical. That's initiation. Once we've done the initiation, we're going to move on to step 2, which is known as propagation. Okay? All right. So in propagation, here's what's going to happen now. This is where the ethane is going to get involved for the first time. So here we have, I'm going to draw back my ethane that we drew in the previous part of this question. So here it is. This is my ethane molecule. Just showing all of the hydrogens here. So that's ethane, right? The radical, one of these radicals is going to react with it, right? So the radicals are very, very reactive species, right? Because what's happening now is that it has this electron on it that's unpaired. And so it's really, really reactive. It's really trying to get back paired up. So it's very, very reactive. And so what it's going to do is if we look here, right, all of these are single covalent bonds. So there are 2 electrons here, 1, 2. One came from the carbon and one came from the hydrogen. So what this radical that only has 1 on it is going to do, it wants another 1. So here's what it's going to do. It is going to come and pair up with the hydrogen, and it's going to be like, okay, give me this one so that we can get together, right, and form HBr. And then what will happen is that this electron will then go and land on the carbon. And I'm showing a half hook because only one is moving, right? So in the end, what's going to happen is that because one of them is going to end up on the carbon, we're going to form a radical with this part that remains, right? So let's just put that there. Radical, because that ended up there. And then the H, that H is still there. But this H, right, was taken away to go and be with the Br radical. So that's HBr. Okay? So that's HBr. And here, this is a ethyl radical. Okay? All right. So now, once we have that happening now and we have our ethyl radical, here's what's going to happen. The ethyl radical is going to come down here now. So let's just write the ethyl radical down here. So this is our ethyl radical. The ethyl radical is going to see another molecule of BR in that mixture, right? And what it's going to do is it's going to cause the BR to then split homolytically again. So it will go like that and go like that. And so in the end, what's going to happen here? We're going to end up with 2 bromine radicals again, right? And that's because this radical saw the bromine and was like, hey, I want to pair up with you so I can get one of your electrons so that we can both have 2 and be happy again. And so it will end up now that the Br gets added on here, or one of the radicals is going to go here, and then the other radical gets left alone. So now we're going to end up with this. H, and then the Br gonna get incorporated in there with that ethyl radical. And then now we're gonna have a Br radical that's remaining by itself. Okay. And so this is how we would have gone through our first substitution. Remember, whenever we have alkanes going through a free radical substitution, if we have enough alkane and enough Br, we're going to get a complete substitution where all of these hydrogens are going to get substituted out with Br. But for the very first step, that's what we've just shown in this propagation here, where we ended up here forming this first one, which is a what? 1 bromoethane, right? So let me just write that there. That would have been just 1 bromoethane, where only 1 bromine got incorporated in. Now, assuming that we have more bromine molecules laying around, then we can continue to propagate and go through and take off this one and take off that one, right? And that's what we'll continue on. So that's the propagation step. I've shown it for just the first substitution. You may be asked to show it for more, right? In a more specific question, they might get that specific and say show 2 substitutions. But for here, we've just shown 1. Okay, so we've shown initiation so far and we've shown propagation. Now we have to show termination. So let's see. We're going to show termination. I'm going to clear some space over here. And I'm going to put termination up here. Okay, so here's the termination step. Now it means that we're closing off everything, right? Terminating everything. And so the termination step, the key thing to remember is that the termination step, really what's going on is that you can just imagine searching through the solution, right? A mixture of P with bromine or ethane with bromine. You're searching through and you're looking for any radicals that didn't engage in any reaction, and you're going to pair them up with one another. Okay? So we're going back through the mixture and we see that we see a Br radical and we see another Br radical just hanging out that didn't get paired up. Well, they want to get back together because, again, this is very unstable for them to just have an unpaired electron on them. And so they're going to come together and form Br2, and they're happy and stable again. In another case, we can have an ethyl radical coming together with another ethyl radical, right? Assuming that it wasn't cleared out of the solution or it didn't react, it didn't find anything to react with. So it was just there at the end. It will pair up with another radical that looks just like it. So that's what we're showing here is 2 ethyl radicals pairing up with each other. And what's going to now happen is that that's going to form, that's going to actually end up forming butane, because now we're going to have 4 carbons in that structure and 10 hydrogen. So that's butane, right? So that's one way that we can get butane from ethane. Just think about that, okay? If it undergoes a free radical substitution, and then in the end, we have a pairing up of 2 ethyl radicals that would give us butane. So just keep that in mind, okay, as something that could potentially happen. So here we have 4 carbons and we have 10 hydrogen. So that's butane that gets formed there. And then the final kind of termination, so there are 1, 2, 3, is that we have our ethyl radical, right? So we can have an ethyl radical then that didn't get used up, and that's going to come together with another bromine radical that it sees hanging out there, and then that would form our one of our bromoethane molecules, okay? So that would be H, 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 Br, H. Okay, and so with that, let's see what else there is. So that's the mechanism. That's all that you need to show: the initiation, the propagation, and the termination. And so let's see what else is being asked of us here. So let's just clear everything here. And then we're going to move on to the other part, which is part 4. And part 4 says we're supposed to identify the type of mechanism that we just outlined in B part 3. And we already know that that's a free radical substitution mechanism. Okay? And so with that, we have come to the end of this question. Definitely give this video a like, subscribe to the channel, and if you look on your left here, you'll see the next video up. And if you look on the right here, you'll find our Module 1 playlist with tons of interesting content that will be helpful in getting you prepared for your exam. So thanks for watching, and we'll see you in our next video.